All right, kids. Welcome back from break. Hope you had an enjoyable time to sit back, relax, and hang out with your families. But it is now time to jump right back into the water as we start to learn a little bit about heat exchange. Our three main things that we're going to focus on are conduction, convection, and radiation. But as you've probably learned by now, there are probably 50 other terms associated with conduction, 50 for convection, and 50 for radiation. It's not just three simple terms, but it's a lot of different things associated with the way that heat actually is exchanged between different objects. I think that this picture here is probably one of the best pictures of conduction, convection, and radiation. Um, because you can see the different ways that heat is actually moving, and it's important. I would almost be able to kind of sketch this out. Obviously, it doesn't have to be as good as this, but just a quick sketch of conduction, convection, and radiation. Obviously, as a brain dump before you jump into a test or something would be something good. And this picture shows up very often. Matter of fact, I think there's a picture very similar to this that shows up often on the tests. I've seen something similar to this on benchmarks and EOGs. So it's just one of those things you kind of want to put in the back of your head to kind of keep there as a reference for heat exchange. A little bit of a change from this year as I went back through the notes. I don't know that we really ever dug deep into exactly what is heat. We kind of just jumped into conduction, convection, and radiation looking back at the notes from last year. And I think it's important to stop for a moment and pause and actually define what is heat. Well, heat is actually a form of energy. It's sound is a form of energy. So you have sound energy, electric energy, mechanical energy, chemical energy, nuclear energy. They're all different types of energy. Heat is also a form of energy. And you could define heat as this, and the definition is down here. Heat is a form of energy that is transferred between objects with different temperatures. So if you happen to have two things sitting beside each other and they are both the same temperature, there's not going to be any transfer of heat, no energy being moved from one thing to another. There needs to be a difference in temperature. The other thing that you need to understand is heat flows from the hotter object to the cooler object. It moves from one object to the other because of the difference in temperature. The cool object is actually absorbing that heat energy and it actually becomes warmer. And we'll get into some scenarios like that here in just a few minutes in the slides. But it is important, and if there's anything that you need to jot down, and I think I actually highlight this again later, but it's this right here. Heat flows from hot objects to the cooler objects, or heat flows from the warmer object to the cooler object. I don't know that I want to necessarily say hot objects. I may go back and edit that because it doesn't have to be hot for heat to transfer. I don't think that our hands are necessarily hot. If I put an ice cube in my hand, there's going to be heat transfer from the warmer hand to the cooler ice cube. It doesn't necessarily have to be hot. So I may go back and change the wording of that. But heat does move from the warmer object to the cooler object. And it could be even something as simple as this. Miss Bullens is typically cold. So if she holds my hand is typically warmer than hers, and heat moves from my hand to her hand to keep her hand warm. So that doesn't mean her hand is as cold as ice. It feels like it sometimes. But that doesn't necessarily mean it's true. This means her hand is cooler than mine. So when we're talking like warmer object and cooler object, we need to understand that there's a difference there. And give me a second. I'm going to jot down. I'm going to change that as soon as I finish this video. So jot down change. There we go on a little piece of paper. All right. Let's keep on moving. Take a look in the background. And so imagine you're holding ice, or get a piece of ice out and hold it in your hand, and the temptation is to say the ice is making my hand cold. And I understand why we would say that. However, we're going to start digging a little deeper into this, and we're going to have a better understanding of what's going on when we put an ice cube in our hand. Now, remember, when two objects of different temperatures touch, the goal of these two things touching is to reach a balance. It's a state that we would call equilibrium, where both of them are the same temperature. And I know you're thinking, well, Mr. Bullens, that's not possible. The ice would melt, it would, and it would turn into water, and eventually the water and your hand, if you could hold it there long enough, would become the same temperature. I got to go back and change this too. I just don't like the wording of it. I think it should say heat will flow from the warmer object to the cooler object. And the heat is moving from your hand to the ice cube. It's not that the cold is moving from the ice into your hand, so it's not the ice is making my hand cold. However, because your hand is transferring heat to the ice, your hand is cooler and the ice is actually becoming a little bit warmer. So what's the big takeaway out of all this? Heat moves from a warmer object to a cooler object. And we're going to go back and change those words. So if you pop into the Zoom tomorrow, you will see that has been changed. Moving from the warmer object to the cooler object. We need to go back and look at this as well, the changes of matter. And remember when we had solids, liquids, and gas, and we looked at the way that a solid could melt. We looked at the way a liquid could freeze. We looked at how solids, say dry ice, could sublimate and turn directly into a gas. And if that's possible, then we know that gas can turn directly back into a solid. Now notice they call it deposition here. We said desublimation. Those are the same thing. And this example here is like frost forming on your window. We know that liquids, when heated up to a certain temperature, will evaporate and turn into a vapor and turn into a gas. And we know that gas, when it cools off enough, especially when it rises up into the atmosphere, will condense and turn into tiny drops of liquid. And we know that condensation is how cloud formation happens. We need to remember all of this and kind of what's going on inside of each of the states of matter, especially with the molecules when we look at that. So, take some time, pause the video, make sure you have this in your notebook again. But Mr. Bullens, I drew it last quarter. I don't care about last quarter right now. I care about now, because this is going to keep coming up, and I don't want you to have to keep flipping back to other pages of other topics when you can just put this one under heat exchange. So take the time to do that. I know we're going to do that in class as well tomorrow. Now remember this triangle. Don't forget this triangle. We got to think about when heat is being added and when heat is being taken away. And we got to think about what does that do to the molecules. So for example, if I'm moving from a solid to a liquid, I have to remember what solid molecules look like. I have to remember what the liquid molecules look like. And we used water as an example. And we know that solid molecules are super close, liquid molecules a little further apart. So what's happening is, as we add heat to a solid, the molecules start to move more and more and more, and they start to spread further and further apart until they eventually change state. And that's kind of shown here. Here's our solid, super close, liquids a little bit closer together, a little bit jumbled up, and then gas. Obviously, a lot more heat has been added. Now, to go from this to this, we got to cool it off. We got to take heat away and have the molecules get closer. And then if you went from water to ice, you'd have to take even more heat away. And again, you can actually go from gas to solid or solid to gas. And we talked about that with the triangle that we just looked at. So all of these things are super important. And I know the temptation is to say, well, Mr. Bullens, I've already put those in my notes. Why do I have to do that again? Because it's going to keep showing up. We build in science on our prior learning, and this is one of those times where we're going to continue to build on our prior learning, because this is not something that's just going to go away. You have to have that fundamental understanding of solids, liquids, and gas, and you have to have a fundamental understanding of this triangle here and the way that matter changes to different phases of matter. Here's a great video that kind of gives you the basic introduction to conduction, convection, and radiation. I think it's a good video to watch. I obviously can't play it on here because it's not my video. So take the time out to watch that. It's the only thing I don't like about recording these videos is I can't show you the other videos that I typically show in class, and I'm just assuming that you're going to stop and watch that. As we stop and watch that during a Zoom, we're going to have conversations about that, and those conversations that we have in the Zooms often lead to some learning and understanding. I understand people watching these videos when they can't make it to Zoom. I just think you're going to get more out of the Zoom than you would just kind of doing this on your own. But that's up to your schedule and how you work things out. Now, conduction. Conduction is the passing of heat through material while the material itself stays in place. And I know you're thinking, well, Mr. Bones, that's a very weird definition. Conduction is the passing of heat when two things are touching. Remember the example of the ice in your hand. That would be conduction. Why is it conduction? Because my hand is touching the ice. My hand is the warmer object. It is transferring heat to the ice, which is the cooler object, and eventually they're going to reach a balance or equilibrium if I keep it there long enough. But for the very first few moments of that, the heat is moving from my hand to the ice. And because the two things are touching, we would consider this conduction. If you've ever cooked with metal pots on the stove, you know that you need a pot handle to grab the pots unless they are made of plastic or wood or something that doesn't conduct heat as well. But if they're made of a metal, like the whole pan is metal, you can't just grab the pot handle. It'll burn you. And when you touch something and get burned, that is heat transfer through conduction. All of a sudden, your hand is not the warmest object anymore. This is a pretty hot object, and it will burn you if you're not careful. Here are some examples of conduction. I've seen many of these show up on tests and quizzes and benchmarks and EOGs. Cooking an egg on a stove. The egg is touching the frying pan, therefore the heat is being conducted through conduction. It's being moved through conduction. Ice melting in your hand. We've already talked about that. Burning your finger on a spoon that's in a cup of hot coffee. So you make a cup of hot coffee or hot chocolate and you put a metal spoon in there and you leave it for a while. That spoon is going to get some of the heat from that hot liquid. When you touch that spoon is going to transfer the heat from it to you, and because two things are touching, all of a sudden it is going to be conduction. Sometimes, and I'll have to ask Ray about this if he has any animals at the farm that do this, animals will dig out like a patch of dirt. Elephants do this, dogs will do this, and they will dig out a patch of dirt and they will lay in that. And the reason why they're laying in that is because the ground is cooler than their body, and the heat moves from them to the ground, thus cooling themselves off. And that is going to be another example of conduction. Convection. Convection is the transfer of heat through a gas or a liquid. So if you are outside on a windy day and it's hot, that hot air that's moving around you is convection. If you are outside on a cold day and the wind is blowing around you and it's cold, that is heat being pulled away from your body, that is convection. If you have something boiling on the stove, that is heat moving through a liquid, that is also convection. We're going to take a very good look at this right here. Go ahead and get used to this. This is called a convection cell. This is huge. It's an important, and it's one of the first things we're going to talk about when we get into weather. And you have to have an understanding of conduction, convection, and radiation in order to understand weather. That's why we teach this first. But this is a convection cell. You're going to notice the hot water rising and the cold water sinking. And that's why you can kind of watch the macaroni noodles bounce up to the top and sink to the bottom if you've ever watched something boiling on a stove. Boiling an egg in a pot of water is convection. Why? Because the heat's being transferred through a liquid. The movement of thermal energy around the earth. We will get into that more in class, but that is convection because the sun heats up the earth, hot air rises, cold air sinks, and that's going to be that convection cell that we talked about. And anytime you have boiling water where the cold water is going to sink and the hot water is going to rise, and we will take a look at that in an experiment in class pretty soon, but that's going to be convection as well. We are going to stop there for now. We will pick back up with radiation later on. And again, don't forget to study your vocabulary this week, as that's going to be important, and continue to follow along with me as we do our reviews, as our benchmarks are next week. Have a good one. Don't forget to smash the like button and subscribe.